Section 2.8, Graphing Inequalities. These are largely just more graphing problems with two exceptions. So to start, once they become inequalities instead of equations, there's going to be shading involved. We're going to color in part of the graph. And second is that we always want to look at the sign and determine whether or not we want to have a dotted line or a solid line. So first step, let's graph the line. Okay, so we look at this. This is in point slope form. We can pick out the slope as 2/3, opposite of both these numbers for the point, -4, -1. All right, let's go ahead and graph this line. So we're going to start at that point, -4, -1, and then move based on the slope, up 2/3. All right, that gives us our line. Now, before we actually draw the line, we want to look at this sign. So it's a less than or equal to sign. Okay, as long as it has that or equal to sign, we're going to have a solid line. If it didn't have that and it was just a less than sign, it would have been a dotted line. Okay, so we have our line. Now, the other thing we want to figure out is which way to shade. One way we can do that is by plugging in a point. An easy point to plug in is 0, 0. Okay, as long as the line doesn't go through 0, 0, okay, we can always plug in that point. So if we plugged in 0, 0, we have a 0 here, so it's just a 1 on the left side. Okay, and then we have 2/3 times 4. Okay, 2/3 times 4 is going to be 8/3. Is 1 less than 8/3? It is, so we would shade the bottom. All right, the easier way to do this is just to look at this sign. It's a less than or equal to sign. When you see less than, think below and shade below the line. Here we have an absolute value equation, so you should realize right off the bat that this is going to be a graph that's shaped like a V. So let's start off by figuring out what the vertex is. So opposite, same, vertex is -2, -1. Slope is this number here, slope of 1/2. All right, so we start at -2, -1, and we're going up 1/2. Okay, it's a less than sign, so this time we have a dotted line. All right, looks like this. And if we use that trick that I just mentioned on the previous slide, okay, we are going to look at that sign. It's a less than sign, which tells us we're going to shade below the line. Right? Everything underneath our absolute value sign gets shaded, which means we're shading all this area. Here we have an equation in standard form, which means the easiest way to graph it is using the intercept method. So intercept method, we're going to plug in a 0 for the x, and that's going to tell us what the y-intercept is. So 0 for the x means that 3x is gone. We have -4y. Let's pretend it's an equal sign. So -4y equals 12. We get a y-intercept of 0, -3. Same thing for the y. Okay, now we're going to plug in a 0 for the y, which means the y is gone. 3x equals 12. X-intercept is 4, 0. Okay, we're going to plot those 2 points. Y-intercept 0, -3. X-intercept 4, 0. Graph the line. Okay, so we have a dotted line. And when we look at this, this is a greater than sign. Now, if we use the trick for this, okay, it's going to actually give us the wrong answer because this graph is going to be shaded below. Okay, that's the opposite of what that sign says. Because that sign greater than would tell us to shade above. Okay, the way we can figure this out, and there's a trick to it, but if we plugged in the point 0, 0, okay, 3 times 0, that's gone. 4 times 0, that's gone. 0 is greater than 12. That's not. This side is false. Automatically, the other side is true. This is the side that gets shaded. Okay, the reason why it doesn't work, this little shortcut trick of looking at the sign doesn't work for this problem, is because if we were to rearrange this equation, okay, into slope-intercept form, so we move that 3x over. Now we have negative 4y is greater than negative 3x plus 12. Okay, it's this step which causes the problem. Anytime we have an inequality and we divide by the negative, we have to flip that sign the other way, and it ends up as y is less than 3/4 x minus 3. Okay, so anytime we see a negative that's attached to the y, like it is here, that sign really flips the other way. Okay, it becomes a less than sign. All right, that's why it's below. If you keep that in mind, that trick always works. Lastly, these are simple and intuitive. Is the following ordered pair a solution to the inequality 5x minus 2y is greater than 5? Let's start with the ordered pair 2, 1. We're just going to plug in the x and the y. So here's our inequality, and now we just evaluate it to see whether it's true or it's false. We get 8 is greater than 5. That's true, so yes, this is a solution. Okay, if we plotted this on a coordinate plane on a graph where this is graphed, it would be in the shaded section. Okay, continuing, if we plug in 3, 5, right, we get 5 is greater than 5. That would be exactly on the line. Since it's a dotted line and there's no or equal to sign here, this one is not true.